Welcome to the Explainer. Right now, we're unpacking a literally high-stakes, real-world operation unfolding in one of the most absolutely critical maritime choke points on the planet. I'm talking about the Strait of Hormuz. You know, what happens here doesn't just stay here. It ripples out, impacting global trade and energy markets for all of us. And we're seeing a really fascinating shift in military tactics. It's no longer just about having the biggest, baddest hardware. It's about creating this unbreakable, perfectly timed loop of action. We are talking about absolute airspace denial. Okay, let's dive into this. What does absolute airspace denial actually look like in practice? Well, the core problem we're seeing in the source material is how to effectively counter a modern asymmetrical threat, specifically incoming drone swarms, and doing it with a relentless, never-stopping operation. Because, guys, it's not about winning a single flashy dogfight. It's about establishing a defensive posture that literally never sleeps. How on earth do you completely lock down an airspace that complex? So the material really highlights a fundamental shift in the operational dynamics in the region. On one side of the equation, we have Iran's strategy, which uses these asymmetrical drone swarms to exert control over the waterway. And on the flip side, the United States military has deployed a pretty overwhelming countermeasure. It all relies on this absolute clockwork rotation of AH-64 Apache attack helicopters. They're staging out of bases in the UAE and even flying directly off the flight decks of naval vessels. And to be clear, this isn't some temporary surge. It's a permanent revolving door of airborne gunships, constantly hunting for drones that might try to target naval assets or commercial oil tankers. Now, to understand how this actually functions on a technical level, we really need to look at the integrated kill chain. Honestly, this is the core focus of our explainer today, because what's truly fascinating in the data here is that the initial warning of an incoming drone, it doesn't even originate from the helicopters themselves. Now, it starts way deep inside the combat information centers of Arleigh Burke-class destroyers out on the water. It's this massive, multi-domain network that directly links the incredibly powerful surface fleet radar straight to the airborne gunships. You can really think of this entire process like a high-speed relay race. So step 1, radar operators down in the Arleigh Burke destroyers track these low-altitude contacts. Step 2, the very millisecond a contact is classified as a hostile drone, that telemetry data is instantly data linked right into the Apache cockpits. Step 3, where the Apache's sitting on deck alert, those twin turboshaft engines spin up, the main rotor engages, and the gunship lifts off the pitching deck, immediately vectoring toward the exact threat coordinates. And finally, step 4, the Apache closes the distance. It uses its electro-optical and infrared sensors to visually acquire the drone and execute the intercept. It's just a seamless, incredibly fast handoff from the ship right to the chopper. And the absolutely crucial point here is the speed. I mean, from the moment that ship radar paints a target to the moment those Apaches lift off, the reaction time is measured in mere minutes. That's it. There's no time for long tactical briefings, no delayed spool-ups. It's an instant, rapid-fire execution driven entirely by real-time data from the surface fleet. And this brilliantly illustrates the tactical mismatch once that Apache gets airborne. Look, you have Iranian Shahed drones, right? They are essentially designed to hit static targets flying on a very fixed, predictable trajectory. They're rigid. But pitted against them are the AH-64 Apaches, which are incredibly dynamic. The source notes that the Apaches just effortlessly outmaneuver these drones, completely destroying them long before the drones can ever reach their terminal dive. The pure agility of the helicopter completely negates the entire swarm tactic. Section 1. The hot turnaround and its brutal efficiency. Okay, so keeping those agile gunships in the air, that requires massive, and I mean massive, logistical support back at the ground staging bases in the UAE. Because when an Apache returns from patrol, it doesn't just park and power down. Maintenance and ordnance crews immediately swarm the airframe for what's called a hot turnaround, and the armament layout they're hoisting onto the airframe is highly specific and, frankly, totally devastating. For surface swarms, they mechanically lock on pods of unguided Hydra 70 rockets. For the drones themselves, the primary weapon is the M230 30mm chain gun, which fires high-explosive dual-purpose ammunition. And then, for much heavier targets, think fast attack boats or hardened coastal bunkers, load crews physically slide laser-guided AGM-114 Hellfire missiles right onto the rail launchers, plugging in the electrical cables and locking the mounting lugs. It's a heavy-duty process. Just to give you a real sense of the sheer scale of firepower being loaded up during these hot turnarounds, a single Apache can carry up to 4 of those rocket pods. That gives the pilot an astonishing 76 individual high-explosive rockets ready to completely blanket a surface swarm. 76. And it turns out every single one of those rockets has to be manually inspected by the ground crew before the pod is even sealed. But while 76 rockets is a massive macro-level threat, the micro-level precision is just as impressive. That 30mm chain gun mounted right beneath the nose, that's the primary drone killer. Ground crews are constantly feeding it fresh belts of high-explosive ammo. But what makes it truly lethal is that the gun tracks seamlessly with the pilot's literal helmet movements. So the gunner literally just has to look at a drone, pull the trigger, and boom! Instantly shreds it with a burst of heavy cannon fire. And within minutes of touching down, the gunship is fully armed, fueled, and thrust right back into the combat rotation. Section 2. Unbroken logistical supply lines. Now, of course, machines break down, right? Airframes get fatigued. To guarantee absolutely uninterrupted patrol coverage over the strait, this whole logistical supply line relies on kind of an unsung hero. The arrival of a massive C-17 Globemaster III heavy transport plane at a nearby desert airstrip. Its cargo is a fresh AH-64 Apache, flown in directly from the United States to replace a damaged or tired airframe. But transporting an attack helicopter inside a cargo plane, that requires severe spatial compression. The airframe has to be partially disassembled. And what I found really striking in the source material is that the offload is entirely manual. Ground crews are literally pulling out these heavy wooden crates using carts and forklifts, crates holding the rotor blades, the stub wings, the avionics. And then, resting on unlocked landing gear, the massive stripped-down fuselage is carefully pushed down the steel ramp by sheer manpower. It requires incredible coordination to maneuver a multi-million-dollar machine like that without damaging its super-sensitive chin-mounted optics. Let's move to and see how this builds, because once that fuselage is finally pushed onto the concrete, a military tow tractor hooks it up, the component crates follow right behind on a flatbed, and the convoy heads straight to a secure hangar. Then, it's like a pit crew. Aviation mechanics step in and operate with absolute surgical speed to put this massive, multi-million-dollar puzzle back together. They hoist and bolt the main rotor blades, attach the tail rotor, reattach the stub wings, and intricately hardwire all the weapons pylons right back into the firing computers. Once it's all reassembled, the mechanics run a highly comprehensive diagnostic check. They're checking absolutely everything, verifying hydraulics, running through electrical systems, synchronizing the flight controls, and precisely calibrating the weapons targeting. And the very second those diagnostics read green, that fresh replacement Apache is not being put into storage, no way. It is cleared and thrust straight back out into immediate combat flight to maintain that unbroken perimeter coverage. Section 3, the cycle repeats. Because out over the waters of the Gulf, the cycle literally never stops. The combat alarm echoes across the deck of an Allied warship as the surface fleet's radar paints a brand new wave of Iranian attack drones launching from the coastline. Immediately, another staged AH-64 throttles up. Its rotors blur, and it rapidly accelerates toward the threat. The gunner locks in. The thermal signature pops up on the multifunction display. The helmet-mounted sight perfectly aligns that 30mm cannon. The trigger is pulled. And just like that, another target is destroyed. Crucially, as part of that integrated kill chain we talked about, the successful engagement is instantly confirmed back to the surface fleet. The gunship banks away, seamlessly returning to its holding pattern over the Strait of Hormuz. The airspace remains completely locked down. Which really leaves us with the ultimate question as we wrap up this explainer. The blockade is technically broken by this continuous, overwhelming countermeasure. But with an unending 24/7 rotation required to hold the line, how long can this incredibly complex, multi-million-dollar clockwork of radar ships, helicopters, hot turnarounds, and heavy transport planes actually sustain this lockdown? It's a massive logistical and operational feat for sure, and one that absolutely redefines modern airspace denial. Thank you so much for joining me on this deep dive. Keep questioning, keep learning, and I'll catch you in